Thank you for being there.
But I really like your reaction.
I'll be the designated art director. You should have showed up 2 years ago.
Hello, everybody. We are ready to start. Do we have a note check? I think we can monitor Tsvarea also.
Yeah.
The three of us. Okay, welcome to the Tsvarea meeting. My name is Mia Kühlewind. I'm one of your ADs, and I will be here for another year.
I am Spencer Dawkins. I am the outgoing transport area director, and I have been for a long time now.
And I'm Magnus Westlund, and I start tomorrow formally, but yeah, I think you've seen me.
Here you are.
Yes.
Tomorrow. Okay, so we're ready to start. This is an IETF session as every other, so there's a note valve for you. Same rules about participating, and I hope you will all participate very much today because we have some nice topics and hopefully some nice discussions going on there. Yeah, that's our agenda. So we started right now. We can bash the agenda if you want to. And then after the agenda, we will briefly talk about the situation that came up, that like up from tomorrow. You will have two ADs with the same affiliation. So we give you a chance to comment on that. And then we have some technical talks here. The first one is a little bit of follow-up from the discussion we had last time. And then we have 3 talks which will talk about logging. Those talks came basically or were motivated by Quick, but I hope that the discussion we will have afterwards will be more general. And then if everything works well, because the agenda is very crowded, we will have like a few minutes for open mic questions at the end. Any agenda bashing? Great. Yes. So very much welcome, Magnus, and also very big thanks to Spencer, who like served for 6 years and did a great job. He just said it seemed longer. So that's also kind of the usuals we have here. We have a review team meeting, which we as ADs rely on doing reviews, and they were very productive not productive, but very supportive, very helpful over the last couple of months and years. So that works better and better, and these are very valuable reviews for us. And we have 3 new members, Olivier, Gori, and Tommy. So thank you, everybody, for serving, and especially the new ones.
Yes.
One of the biggest things that helps us is the triage team, and Transport has a unique area, review team, which is we don't do all the documents. We have a triage team that looks at the documents and says these are the ones that are going to need special transport attention. That is a real gift to the area directors. Magnus has been performing that role for a bit more than a year. He will not be performing that role anymore, and Maria and Magnus would like to replace Magnus as one of the triage team members. You don't have to be a former transport area director to qualify. I'm just saying.
Wait. But you can be. Okay. Then this one is easy. So we do like a straight switch, like Magnus will take over all of Spencer's working groups. So you don't have to be completely confused about it. And I will just keep the working groups I've been responsible for. So hopefully that should be easy enough. So finally, I mean, I'm saying this since a couple of meetings now, but finally I actually will close TCP Inc. in the next coming of weeks. And we will also close the mailing list. So if you have any last questions for the TCP Inc. people, post them now.
Yeah. I mean, otherwise, I think I'm learning the working groups, I'm talking to shares, etc., and coming up to speed here. So trying to figure out exactly what I have in those group I haven't been active before in. But so don't hesitate to talk to me about them, those groups, etc. Provide your views, etc. So thank you.
This is also the usual slide we have. That's the progress we made since the last meeting. We find this nice to have because it shows that we do some work, but mainly it shows that you all do some work. So again, thank you at that point. A lot of clapping here. Yeah, and this is a discussion that just happened in a previous session in TSU working group. So there was a presentation about using H2 as a more generic transport byte stream protocol, basically, which is related to a discussion we had last time at TSU area, and therefore also a little bit related to the first presentation we will have later on. Talking about other topics that might be interesting for you, later today there's also a MapRG meeting, not later today, later this week. There's a MapRG meeting, and there are a couple of talks which are very relevant for transport, so keep that in mind. So that's on Thursday. Do you have something else? And looking back, but also coming back in some of the sessions this week, there have also been a lot of presentations which were related to transport in the hot RFC session. So that's an indication for us, all these things together, I think, that we do expect more work. Like my feeling is that like we got over the shock we got with Quake a little bit. Now think about like new funny things we want to do. So I think that's actually a good thing because we will and have been closing some groups. So I think we have actually some capacity here to think about new ideas, especially if you're planning above for the next meeting. Come to us, talk to us early. We can help you. We can give you feedback. If you put in your BOF request in the last minute, chances that it will make it are less, because if we don't know what you're talking about, we cannot really make a decision. And if you tell us early, we can really help you to figure out what the right scope is for your BOF as well. So this is like a sneak preview for the next meeting, actually, because that's a topic that came up from the IAB, but it's also a topic I actually talked to a lot of people independently this week. People actually came to me and talked to me about it, about like concerns that the freedom we get with implementing stuff in user space and being like much more flexible about the protocols we design, which is a good thing, can also take away some of the gatekeepers with respect, for example, to congestion control. So that's a discussion that started already on the ICCRG mailing list. So please go there and contribute to the discussion if you have thoughts. But this is also a topic we would like to discuss at the next meeting in Montreal because we didn't have time this time. So it's the right time to think about it right now and then come to us until Montreal.
And thank you, Christian Wiedema, for starting this conversation.
Yeah, Christian or Brian, do you want to add anything to that point?
I'm doing this to give you all a picture of what it's going to look like this coming summer. So like kind of visualize that as the two area directors you will have then are talking now.
Yeah. So conflict of interest handling. So the situation now is that both me and Miri are employee of Ericsson's. We're actually quite close in the organization too, internally. So there are an increased risk for conflict of interest situation now, and this is something we are well aware. But we will try to talk a little bit about how we see on this and how we plan to handle it. So basically, our basic strategy for handling cases where there's any perceived conflict of interest is to actually hand it over to another AD to do the decisions or the handling of that situation. And some examples of this would be like IPR issues related to any transport document, etc., that involve Ericsson IPR or employees. Like AD sponsoring a document, we wouldn't do that for an Ericsson author. That was also something we would have to hand over. If we end up in situations where the working group has difficulties and agreeing or the chairs disagree or leave the consensus decision or call for the issue to the ADs, that happens occasionally. That would also be, if that involves anything with Ericsson, that will also be something we would recuse from. If we have working group shares at Ericsson in a working group, all working group shares, I would say, and that's something we're going to avoid having. But if the situation occurs for some reason, it might be that we actually lose a share and only have an Ericsson share left, things like that. And in case of complaints against the working group share, let's say the Ericsson person. So one situation I want to stress that we don't consider really being in the normal situation be an issue is that some author is from Ericsson of a working group consensus document, because there's several authors, there's working group chairs, and there's consensus from the working group on this document to process it. So in those cases, unless someone requests that they feel that it's a sensitive issue, etc., or if it is some other additional issues around this document, we will handle those according to our normal working group assignments in the area. So, any comments on this?
Spencer Dawkins, just mentioning that this is copied fairly closely from the plan that the routing area used when Aaliyah and Adrian were both funded by the same funder as well. So this should work, and it will work better if everyone helps the area directors make it work.
Let me add one point. So it's really not a problem to hand over any kind of things, a working group, a document, or whatever, to a different AD from a different area. We do this from time to time for like various reasons. So we are all equipped for that one. And we will be very sensitive to try to figure out if there's any conflict. But more important is also if you feel that there is a conflict, please come and talk to us and tell us.
Colin Perkins speaking as an individual when I get close enough to the microphone. So I think this is a very sensible plan. I would perhaps suggest that in cases where that there is a preponderance of Ericsson people, for example, if in the case where all the authors of the documents are also Ericsson people, we have a very effective transport review team that could do a sanity check on the document.
Yeah. That's a good suggestion. Thank you.
Lars, I don't see a problem with this. It's a good approach, and thanks for writing it down. So would I be correct in summarizing this? So even if an area where you have two different affiliations, like we have right now, there are cases where the AD responsible for something would hand that over because of conflict of interest, and now you're basically handing it over, except you're handing it outside the area.
Yes,
that's roughly what you're doing here.
Yeah,
right. That makes total sense.
I could just to respond to Lars, I myself have shepherded a routing area document for this very reason. The thing that we picked up in the last 2 or 3 years ago probably was the ability to move an entire working group responsibility to an area director in another area, but leave the working group in the right area with their peers. That was something that we got when Benoit was doing Yang, and several other area directors picked up his groups from a completely different area, but they stayed as ops groups. They just had an area director that was outside of ops.
Hi, Bob Briscoe. Yeah, all seems fine to me. The only thing I would question, if thinking about this from the point of view of someone who feels there's a conflict of interest, they may not want to come to you to convince you there's a conflict of interest. You say, we will hand it over.
No, that's not what I meant. So if you feel there's a conflict, you can talk to us directly if you want to. But probably the best to talk to is somebody else in the ISG or the IETF chair or your chairs. And everybody is aware of the situation. And I think we all are aware that we should handle it carefully, yes.
Yeah. And I think that needs to be documented so that people who, we're all your mates, we know, we trust you, but someone who feels outside of the system.
So I did send an email to the community about a week ago, maybe 2 weeks ago, and in this email I did actually explicitly say, come to us, come to the ISG or the IETF chair.
Florin Babuescu, Broadcom. My question to you, it may be okay. However, is there any binding document detailing these details once the meeting is done?
You mean an RFC that documents the behavior we should have in this case? Excuse me? You mean an RFC that documents this? So actually, this is what Lars said. This is not, you can always have a conflict of interest. And we behave in the same way as we would with every conflict of interest. Just because this is a situation where a conflict of interest could happen more easily, we will just be more careful about watching it.
So again, if I might continue, as I have Lexi multiple SDOs, at the end of the day,
if I could actually, I was about to say something that you're moving right in the direction of what I was going to say. So what I was going to say was important. Remember that this SDO, we all participate as individuals. So what we have here that other SDOs don't have is more running code about this. If you think about the number of router vendors that have provided leadership to this organization for a period of decades, we've had to, as a culture, deal with this issue very deeply. So this is something that's come up a lot over a period of decades. Having said that, you all are doing exactly the right thing and providing feedback to the new area directors about the way you expect things to work. Please continue. But I'm just saying, don't look for a lot of documents about this because it's been in the culture for decades. That would be my answer.
Again, at least from our perspective, we would like to see more clarification, and maybe it's a good time to take a step forward and clearly state it.
I mean, I don't have the reference right now, but I believe there's more text about conflict of interest handling in general. However, if you feel it's not sufficient, you're part of this community. Like, we're happy to take some input and have more discussion about it.
Hi, Brian Trammell. I was just going to say that, yeah, a few paragraphs updating 2026. If people in the community feel that that's necessary, it's not that hard to write an ID.
So I would be interested to know if there's anything particularly that you feel needs to be clarified here. I mean, obviously the NOMCOM rules try to avoid the situation we're in. However, right, the slate was such that there was no other good option, and so we have two employees from the same affiliation, and that's not the first time this has happened. Is there anything that you think is missing here, or just in general look for more guidance?
Yes. So again, even the fact that we do have this conversation right now, it shows that maybe it would be better, like also a previous speaker said, including a couple of paragraphs detailing what type of behavior should be expected to be good.
So where I would head with that is if there are things that are specific to the transport area, that's something that the transport area would be in charge of providing paragraphs about. But if we're talking about something, a way that the IETF in general across areas should behave, that's a conversation that we need to have with the larger community. And remember that all of our processed BCPs came from somewhere. So they're not perfect and they can all be changed by the community.
So,
I could see a general level IETF-wide statement on conflict of interest being useful. I'm not sure if we need to be very specific about this particular case, which is like one example, right? Also, I want to point out, having been area director before, right, the spotlight is on you in general, and the spotlight will be on Magnus and Mirja in particular. And there's a well-defined process for, how to get rid of an area director when you feel that they have overstepped the boundaries, and that is well-defined and can be executed, right? And everybody's well aware of that. So the quickest way to limit your term as an area director is by, not being careful about conflict of interest.
Yeah, sure.
Yeah. Okay, moving on. So, a little bit, which it actually comes back to continue on the transport area in general and how our staffing situation. I want like a little bit perspective on this situation, how it arose and why it was hard to avoid, even if we missed. So, I was the only running candidate when signed out from, I think it was around August, when the call for nomination went out. The point where it was likely but not final that we would be hired by Ericsson was somewhere in December. If there'd been a good candidate at that point, I would have had the option of step down if there were a candidate. Otherwise, I would have to reset non-com state. If I told non-com that I don't anymore do it because we might hire, or say it's likely but not final to hire Mirja, I think at non-com I would be irritated at that point. But yeah, they've done their work and replaced, and we've probably been a bit late. But that could have been done. It was final that we hired Mirja just before the non-com announcement went out. So the thing I do like to tell for future years is that even if you think you have a great candidate, please run anyway, because these situations can occur. It could even have been a family emergency or something for me to saying, no, I can't run anymore. And then the non-com process wouldn't have been as far away to selecting any replacement, etc. So don't hesitate to run against people you think is good, etc. You can provide feedback to non-com saying that, yeah, I'd rather see that other person doing, but I'm here if the non-com feels that's the right thing to do. So.
Yeah, let me add 2 points. One is running through the process can actually be an interesting experience. So, yeah, in many ways. But having some kind of a pre-rehearsal before you actually want to do it might be an option for you. And then, because we had this discussion yesterday, from my experience, I've never been in this situation, luckily, but if you actually end up in a situation where you're the only AD for an area, it's doable, but it's a hard situation because you always come, or you over and ever again come in a situation where you have to make a decision, and it helps really to have somebody else you can talk to, and you can also has the expertise, and you can decide together in these kind of things. So don't put anybody in this community into that situation if you can help out, please.
Yeah. So, and then it's the call to arms, so to say. So Miria's term ends in March. I plan to only do one single term, so my ends in March 2021. Non-com will typically ask for nominees around the August, September timeframe. So there's a great chance here. Run this year, run if you didn't make it, or if you can't run this year, run the next year. So, and if you have any questions of what it actually means to be an AD, please go ahead and ask us. So, Tom.
Tom Herbert. So my impression of being an AD is it's a lot of time, like almost a full-time job. Can you comment on that? Because telling us to run is great, but
yeah,
I'm not sure many of us can commit to
you need some backing, but there's different way of running this actually, because I would say there's if you select to offload a maximum amount of work and only focus on the most important things of which you can't offload, there might be some potential for doing this in like I would say maybe 1 to 2 days a week.
That's about what we're trying to do, right?
Yeah.
I was keeping my time very much to 40%, which is 2 days a week, right? And I was really looking for that. Not anymore. Next year I can do more work. But it is possible, and that's another reason why it's important to have a second AD there, because you all have a backup. So even if you go on holidays or whatever, you miss one of the telechats, you miss reviewing some of the document, you have a backup there. So it is possible, but it also means the more time you have, the more you can participate in the things you want to participate in, and the less time you have to do the daily business, right?
Yeah. But yeah, one of these tasks were actually looking at the other documents that comes through. Those part of those tasks can really be offloaded, for example, to review teams, etc. And then if you trust them doing the right thing, you can basically ballot based on their input. I think the IETF share does that basically fully on based on Genart. So okay. Let's see.
Try short topics. Yes.
Yeah.
David.
All right, thank you. Good afternoon, everyone. My name is David Skenazy. I work at Google, and I'm here to talk about MASK. So first of all, apologies for the very convoluted acronym, but turns out all the cool kids are having cool acronyms these days, so why not? So in terms of where this is at, this is a very early thought experiment. I put it in draft form because that's the best way to get IETF attendees to read anything. But my goal is not to publish this in its current shape in any way, shape, or form. It's more to kind of ping people on the concepts and see if A, is there interest in this kind of work, and B, is this completely crazy, or am I doing it horribly wrong? So I already presented this yesterday in Sec Dispatch to really focus on the security aspects, because apparently, according to them, following cryptographers on Twitter doesn't make me an expert, so it's worth getting them to check. And conversely, following transport experts on Twitter doesn't make me an expert either. So that's why I'm here, to make sure I'm not going to break the internet, as we're saying these days. All right, so what is MASK about? as I'm sure a lot of you have been following the news, internet censorship is definitely on the rise. And either state actors or companies providing services for state actors are becoming more and more resourceful and clever about the ways they prevent people from accessing content. So in some cases, we can think that ethically that's not great. And I personally feel that there should be a way for some people to access things that maybe they're not allowed to. In particular, these state actors have been very effective at blocking domains. So there's specific content that they don't want people to connect to, or they want to log if they connect to it. So what's been happening a lot recently is looking at the SNI and TLS, because now that there's more encryption on the internet, that is the part that still really sticks out. But they've been also very actively blocking any kind of technology that allows you to circumvent that, mainly VPNs or ESNI, which is encrypting the SNI. Similarly, DOE, DNS over HTTPS, is being blocked as well. And the kind of fundamental properties is anytime there's traffic that doesn't look like regular web, they block it. And the reason for that is the web is still a huge, huge place. There's a great many number of websites. We want to keep it that way. But it also makes it untenable to have a whitelist for a government, because there's always going to be a perfectly fine website that they haven't heard of. So they're relying on blacklist of specific things that aren't allowed, and then heuristics. So that's kind of our in here of using the fact that my personal website is probably not on any blacklist yet, and maybe I could hide a VPN on my personal website. I hope at the end of this talk, my personal website doesn't end up on a blacklist. But if I were to run like V2IPsec, for example, on it, that's noticeable. That's how I end up on the blacklist. So what Masks does is to make it so that my HTTPS website, which exists today, can also be used by me or maybe, say, my friends as a VPN in a way that doesn't stick out. So in terms of threat model, we have an attacker that's really powerful. So not only can they watch everything that's going by, they can also attack, so send active probes. There's prior art showing that some of these networks will see connections go by and then probe the server saying, oh, do you speak this VPN protocol? And if the server says, oh, yes, I do, then they add them to the blacklist. So we want to protect against that. So here are a list of requirements for what Mask needs to do to achieve its goals. So the first one is kind of from the passive perspective, this looks like HTTP3, quick. It doesn't stick out. It's the same SNI as the website. It's the same ALPN. No funky TLS client extensions or quick transport parameters, since all those are sent in the clear. Another one is you can't detect the server by probing it. So if you send it like a regular HTTPS request, you'll get the web page. But if you send it any kind of VPN message without the keys, then it just says, oh, I don't know what you're talking about. I don't have this web page, or I don't speak this protocol. And another one is because more and more, like a lot of these networks, block quick and UDP, we need to be able to fall back to HTTP2 over TLS, which is still getting through the internet today. In those scenarios, your VPN performance is not going to be great, but that's something we have to live with. All right, so the authentication mechanism I'm going to kind of gloss over, but see my presentation from yesterday. But basically, the client sends a request to the server with a special signature on a TLS keyed exporter, and that gives you the property that the first message from the client to server authenticates the client without requiring a prior kind of requirement to send a nonce from the server. And we also rely on just the regular web PKI TLS certs for the other side of the authentication. Then once you've established that, oh, indeed, I am David talking to David's server, then you can negotiate mask features. So in particular, what do you want to do? The most common one is an HTTP connect proxy. Is, oh, I want to talk to a bunch of other web servers. And so you negotiate that feature. You can go there. Lars, clarifying question?
Yeah, if you want to tell me to wait, that's fine. So I was wondering a little bit about the previous slides where you talked about the properties of the system you're proposing. So it seems to me, at least, not having thought about this much, if I would like to detect something like this, I could simply look at spikes in traffic to servers. Like I'm guessing like your server and my server don't get a lot of traffic. And if they're now hosting a VPN, no matter how, right, that volume is going up. So is this meant for servers that are busy enough so that the increment that Mask would put on them is indetectable? Or
so that's one option. Otherwise, what I personally had more thought of is that the Mask server would be in a different jurisdiction. So, for example, let's say the government of fake countryistan is being really bad to its citizens. The Mask server is, say, here in the or back home in the U.S. Sorry, still jet lagged.
So, but wouldn't the government be able to tell that all of a sudden this URL that isn't local is getting a lot more traffic than it did like last week?
So the idea is to have. So sorry. Oh yes, yeah. I completely forgot to say that in the introduction. It would be to make this very like small localized deployments. So for example, I can put it on my personal web server, give it to like 4 people, and so on and so forth. So like small contests like this, or maybe a big content provider could provide that service before next to theirs. But then if it becomes kind of public, let's say this big CDN is providing this, they might get blocked. So I was kind of hoping to fly under the radar of that way.
That aspect of detectability, I think somebody who isn't a transport person needs to figure out a bit more. But it seems like you might still be detectable simply by the change in volume towards some of these domains.
True, but you would also have for example, if someone writes a blog post about how quick is going to break the internet, there's going to be all of a sudden an increase in traffic. So I think that might be okay. Is Dave?
David Black, Comrade, I hope you got me talking to security folks. Watch out for that fallback mechanism. Security gremlins work there, and that's a topic for another session.
Absolutely, and that actually is a really common one in the fallback between HTTP 3 and HTTP 2. So that's not specific to Mask.
Wolfgang Beck, Deutsche Telekom. The point that has been raised about statistic analysis of encrypted traffic is quite real. It has been used to block voice over IP traffic.
I have some subsequent slide about that. Okay. Where was I? Oh, yes, features. So Connect proxy, so there you can use it to talk to any other web server on the internet. So the main use case would be you send HTTP Connect request for port 43, server creates a TCP there, and then you do TLS end-to-end. Because an important property is the Mask server doesn't see your clear text bytes. If I want to offer this service to some friends to help them, I don't want to get their passwords. But also, that works for any TCP protocol, so the client can access any TCP server. Another one is DOE. Mask can say, hey, I support DOE. So as part of this tunnel, you can just also make DNS or HTTPS requests. Another one is UDP proxying. So this is starting to get more into the transport world. Most, with the exception of DNS, most UDP-based transports on the internet today send a lot of packets in the same connection or session, meaning for the same 5-tuple. In that case, the optimization here is you negotiate with the Mask service saying, think of it like a SOX v5 UDP. I'm going to send a lot of packets to this IP and port, and the Mask service says, all right, I'm establishing a flow for you there, and then you can send quick datagrams with this flow identifier, and anytime the server receives them, it sends them over there, and vice versa. So that allows you to run quick end-to-end, but also WebRTC, DTLS, any UDP kind of connection-based, as opposed to request-response like DNS is, but any connection-based protocol over this. And then for any protocol that is not covered by any of the previous mechanisms, you can have a full-blown VPN here, where you just send quick datagrams with just a full-on IP header, and then the processing is exactly the same as like the inner IP header and ESP payload for IPsec, for example. And then on the server side, you can either send them through or NAT them to kind of hide the client. So absolutely, traffic analysis is a big problem. I can't just hand wave it away, but I am no expert there. And when it comes to privacy, it's impossible to come up with a solution that solves like everything. There are no silver bullets. So what I'm focusing on with this work is at first to kind of kill all the things that are clear text that are really like easy to detect today, to really raise the cost of mounting an attack, to raise the cost of how much processing power, how much money it is for this state actor to detect this traffic. And also, one of the great things about Quick is that you can put a bunch of stream or datagram frames in the same packet, or you can also add a bunch of padding to packets. So that allows you to have, for example, if you have a pattern of how you know your traffic is going to look like, you can feed that into, let's say, the mask server, and it just doles out packet to kind of follow that shape. So, but that I haven't done, I'm no expert there, and I'm hoping it can be some mitigation for traffic analysis. Another cool idea that someone mentioned right after my talk yesterday, which I thought was really cool, is that if you have multiple mask servers and you have an end-to-end quick connection to an end server up there, you can use quick connection migration to switch between the mask servers. So mid-connection, you end up swapping. From the server's perspective, oh, you just had a night rebinding, you're just over here now, everything keeps working. But from a network attacker, assuming that the mask servers are outside of their control and their administration, they have a much harder time doing traffic analysis because they just see kind of slightly less correlatable traffic. Again, not a silver bullet, but the goal here is to keep making it harder and harder. Then a problem that came up for this, yes, Colin, question?
Yeah, question on the previous slide. Hi, Colin Perkins. So obviously this affects the timing, or potentially affects the timing. And if some of the datagram applications you mentioned are real-time applications, you may want to consider separating datagram and real-time traffic so you can do the obfuscation differently for the two cases, and perhaps trade off real-time behavior for easier to detect behavior, which would allow you to know this is not real-time, so you can obfuscate the timing well.
So just to clarify, you're saying that like some traffic that is less time sensitive, we allow it to be delayed and hidden better, whereas the one that really is time sensitive, we take the privacy risk but still have it kind of be visible?
Or you at least give the applications the ability to make that trade-off, rather than enforcing one particular behavior, which would then be suboptimal for certain types of application.
Absolutely. Then it becomes actually the bigger question for this group is, how does the application talk to this? Is there an API? From the server's perspective, the server doesn't even know that mask is involved. It's just a middle box, just a friendly one. From the client perspective, if it's behind like VPN software that's on the device, it might not know either. So that might be, I do agree that that would be great, but actually if people have great ideas for how to do that, that would be helpful. Yes, Bob.
Right, Bob Briscoe. When you've got going, clearly all the requests, the URLs, and all the rest of it can be different within what's being requested, and then that's difficult to see. But I'm thinking of someone looking in the middle of the path at traffic, and
sorry, just in the middle is on the client side of the mask server or on the other side?
On the client side.
On the client side, yeah, the evil, the attacker, yeah.
Yeah.
Okay.
Yeah, and a sub point. I don't think you should call it a state actor, because you can't just define the only bad people as state actors, because other bad people can do things as well. Anyway.
Absolutely, and not all states are bad.
No,
so let's call them bad actors, yes.
Not all bad people are states either. Anyway, the point is, if I attempt to start off the same way as mask, but without the mask, I just access the same website as some other traffic, I will be able to tell that there's a different amount of traffic coming back than in a simple request than in a mask request.
So
So actually, I would, because we have more stuff we want to discuss, right? I would take like the detailed traffic analysis question maybe offline at this point.
Thanks. So let's chat after. But the one-word answer is padding, maybe? Not good enough. Yes. All right. So one of the issues here, as not familiar with any kind of tunnel or VPN, is overhead, which can cause MTU issues. So again, we still don't have really good ways to do path MTU always over the internet. So hopefully the two peers can kind of communicate, and we have some mechanisms for that on what is there, so they don't kind of overwhelm the tunnel. Yes.
Hi, David. Tom Jones. We do have a good mechanism for doing path MTU discovery for tunnel endpoints. It's called DPLP MTUD. And so we can do it across the tunnel. It's the stuff you're tunneling that is the problem, but
yeah,
that's something to talk about offline.
Absolutely, yeah. No, but I agree. For the tunnel itself, yeah, that is great. And then kind of echoing a little bit what Colin was saying, probably if you run like a HTTP connect and you do TCP between the end server and mask, and then quick between mask and the client, you have congestion controllers, one against the other, everything's fine. But if you run quick over mask, then you have one congestion controller on top of the other, and there's no easy way around that, because by design, quick hides all the congestion control information inside the encryption boundary. So that'll be probably like one of the rising challenges of this and many other proposals, I think.
Hi, Colin Peckins. There's an easy way around it, but this group may not like it.
Disable congestion control on the tunnel?
Yeah. I mean, it's implemented in user space, right? And you know the traffic inside the tunnel is congestion controlled.
Absolutely. And I'm going to use that to not plug something. Never mind. Anyway, there are discussions on quick datagrams and how they interact with congestion control. And that is a topic being actually researched right now, because it's not trivial what the correct answer is.
David Black, basically going to second Colin's remarks, both that just having one congestion control is much easier to figure out how to get two to interact, and it is going to be really, really tricky to get sufficient assurance that there's actually a higher level congestion control loop operating.
Absolutely. Thanks.
Andrew McGregor. At some point, someone is going to have to solve the nested congestion control problem. There have been some recent math papers published which actually give me some hope that the problem is solvable, but it's not solved yet.
Could I ask you to share those math papers? I'm genuinely curious, or I suppose the list is as well.
Certainly, I can track them down and post some links.
Thanks.
That brings me to another question. Where do you want to have the discussion continuing?
Actually, which is perfect segue into my next slide. So yesterday at the end of Sec Dispatch, Ben Kadek, Security AD, suggested that maybe having an IETF mailing list for this particular topic would be interesting, and there seemed to be interest in the room. So could I take a quick poll of the room? If we were to create a mailing list there, who would be interested in joining? Raise your hand. Oh, wow, awesome. Thanks. Yeah, I think that sounds like a good next step, because this is very early. Hands again, please. 15.
Taking names.
Yeah. 20, 25? Yeah. Thanks. So, yes, I'll take the action item of making sure this lists happen, and I will announce it on TSV area. But yeah, if you find this interesting, please come and reach out to me. Or if you think I'm a terrible person and I'm doing it wrong, please also come tell me. That's even better. All right, Aaron. And now we're open for any kind of questions.
Yeah, but we have to be quick about the questions.
Okay. So this is very quick. I think this is a really interesting idea. I just wanted to let you know that BBN had several folks working on this, I think under like a Department of State contract. It predates Quick and Doe, and so their solutions are probably pretty different. So, but I'm trying to get some links if there's anything they published, and I'll send those to you in case there's stuff that you can use.
Thanks. That would be incredibly helpful.
Mark Nottingham. I want to encourage you in this work. This is a little deja vu for me because we had a very similar proposal for HTTP2 at the end of its lifetime. And the threat model and the requirements were very similar. You know, no discriminators in the wire, being able to have plausible deniability. And that didn't go anywhere, but I guess the higher order bit is that there was a community that was very interested in that capability, and I still get emails about that occasionally. So there's definitely an audience for this. I don't think it has to be deployed on big CDNs or huge websites. I think the property you're talking about, where I can put it on my web server for my friends, is really cool. And I think there's definitely an audience out there for this. So I'd encourage you to continue. Having said that, although you're talking a lot about Quick and about transport, you are creating an HTTP extension. Please engage in that community to make sure you're doing that well. And remember that to work well, this needs to be implemented in a web server and in commonly deployed home-grade web servers, not just whatever it is today. So, yeah.
Absolutely. My ideal scenario here is that there are packages for all the open source web servers that you can just easily install and then send your friends some keys.
And nice little clients for my iPhone and for my desktop. Yeah.
Thanks.
Wicked cool.
Could I ask you to send me or the list a link to that work that was in HTTP2?
It was a thought experiment. It wasn't really serious, but there was, based on the response to it, it was interesting.
Awesome. And there could be good ideas in there too.
I doubt it, but yeah.
Okay. Thanks.
Hey there, Vladimir Oltanu. So HTTP has a protocol upgrade functionality. Maybe we could use that to upgrade HTTP to SOCKS, and that would kind of take care of some of your use cases?
So actually, this is literally how this works. It's an HTTP connect with a protocol thing. So it's the same way that WebSockets of HTTP2 works.
All
right. Hello, Erik Sü. Did you already made, are you aware of pluggable transports which the Tor protocol is using? Because they also have some mechanisms to hide these or hide the onion routing traffic as HTTP traffic. I think your approach is new as it's touching new protocols like Quick, but they already had some prior work to this.
I'm not aware of that. Could I ask you to send me a link, please?
Yeah, sure.
Awesome. Thank you so much. Yeah. All right. Thanks, everyone, and apologies for going over time.
Right, so that's good. So the intent of this is to start a wider discussion about logging in the IETF. It comes with a bit of a disclaimer though. I'm very, very new here. I mainly do HTTP2 and Quick stuff, so I'm probably going to make some mistakes here. I'm very much looking forward to your pointing out those mistakes at the end of the presentation.
Yeah, let me interrupt you for 1 second. So we have 3 presentations in the same space. So we're running over time already. But so if you have clarifying questions, you can ask it, of course, directly to Robin. If you have want to start a broader discussion, we should do it at the very end, I think.
Yeah. So in the beginning, there was HTTP2. And its core proposal is that you can now multiplex different resources over a single TCP connection. To be able to do that, you need some kind of a scheduler, and the RFC specifies to just use round robin for that, which is also on the slide. But you could also imagine doing something purely sequential, or maybe a mix of the two. So we started looking at H2 implementations to find out what they're actually doing, and for that we were using Wireshark. And it should come as a surprise to absolutely no one here that that got quite tedious quite fast. So what we did was take the PCAPs out of there and make this kind of a visualization. So this is a timeline where each of the rows is an individual HTTP resource, and the blue squares indicate when data is being sent for that stream. So here we can very clearly see number 1 gets a little bit of bandwidth, then number 2, number 3, all the way down. We go back up again, all the way down. Again, a very clear example of a round-robin scheduler. In HTTP2, this is done using what they call a dependency tree, where the nodes in the tree represent the resources, and siblings share bandwidth based on a very simple weighting mechanism. So this is quite straightforward, but this mechanism allows also more complex setups. So we also have this visualization. This is what Firefox is doing, by the way. You can see this is again a timeline, because this tree is not known upfront. It is built. Nodes are added when the browser discovers new resources and are removed when those files are fully downloaded. And that's kind of where our problems begin, because HTTP2 only sends on the wire when nodes are supposed to be added, not when they are removed. So there is no full state sync to keep this tree up to date on two sides. So the previous visualization kind of has to hope that the server follows the spec. The problem is that the spec literally says it doesn't have to. Prioritizations are more like guidelines, not rules, right? For good reasons. But so to actually try to deduce what the server is doing, you have to fall back to the first timeline and try to manually assess what that does. And this problem became very painfully obvious just a couple of months ago when a more generally usable tool set integrated this. So this is web page test. And they updated their waterfall view, and the opaque bits here now clearly identify when the HTTP2 data comes in. Using this usable tool, people then started looking at what our CDNs and hosting providers are actually doing, and the results are actually quite terrible. And if you can start the video, maybe we can see what it looks like if they do it wrongly. So these are both Firefox, but different servers. And I think we can very clearly agree that the right side, the correct side, is a lot better for the end user experience than the erroneous left side of the thing. So this is kind of the state. This is kind of the state of HTTP2 about 3 years after standardization, which I think is kind of terrible. My thesis is that this would not have been the case if this kind of tool would have been usable at the moment of implementation, at the moment of deployment. People might have been more rigorous in testing these cases instead of deploying this kind of behavior. So what have you learned from H2? The wire image itself usually doesn't contain all the information you might want to have for debugging, and this kind of tooling is actually kind of useful in practice. So that's H2, and then, of course, this happens. And I'm only like half joking here, right? Because Quick is exceptionally complex, and not just that. What they really said is, we're going to take all this complexity and implement it from scratch. Believe it or not, there is even an idiot doing a Quick implementation in JavaScript. So we quickly identified this. This is going to be a problem. So we started porting our visualization tools over to Quick as well. Only this time we're not using the PCAPs because those are lacking information. We are now using endpoint logs directly. So we updated the timeline. It's now very easy to compare different implementation behaviors. So these are 3 different implementations, the same test case. One of the streams is being blocked by flow control. The top implementation does not care, just keeps on sending. The second implementation uses Quick's feedback mechanism, using a stream blocks frame to try to get more flow control allowance, but is exceptionally aggressive in sending that feedback. The third one just doesn't do anything. It's okay, I'm blocked. I will just wait around and see what happens. No feedback. So this obviously should not happen, but this kind of tool really helps identify what's going wrong with different implementations. A new tool that we added was a sequence diagram. Quite special here is that we actually combine 2 logs from 2 vantage points. We have both the client and the server log. This allows us to very accurately display things like latency. We know exactly what latency was on the network, but also the latency introduced by processing at the software stack. This also allows us to show things like reordering very easily. You just look for crossing lines in the sequence diagram. It also allows you to very easily see things like where were packets actually lost, and then also how were those lost packets retransmitted. Now in TCP this is relatively easy, not so in Quick. In Quick, at least what happens is you change the packet number on a retransmit. The worst thing that happens is the packet is completely broken down into smaller parts, and those parts can be retransmitted in different packets later on. So if you want to try and debug that and keep track of that, you really, really need those endpoint logs and a good visualization to be able to do that. The last one that I'm going to talk about, it's too complex to go over here all at once. Just focus on the big red arrow, because here we're also logging things like congestion window and bytes in flight. Again, things very useful for debugging, but typically not visible on the wire. So what have we learned from Quick? Using multiple vantage points is very interesting. I've shown you now client and server, but you can definitely imagine having several in-network measurements as well. Let's say a load balancer, a proxy server, that kind of stuff, to get a full end-to-end overview in this single tool. The problem with this was we are basing ourselves on these endpoint logging formats. How that was in practice is we wrote custom parsers for 4 different Quick implementations. And I'm going to show you a quote of one of the students that helped me with this. And he's right. Yeah? Even within the same tool, there are inconsistencies. So this is one of the Quick implementations. 6 lines. At the top you have RECV, which means receive. Then you have RX, which also means receive. And then you have RCV, which very predictably means recovery. Right, so try to strike that. So that's the point where we said, okay, I don't want to do this anymore. Let's try to make something that people can reuse. So we defined like a proposal for a standard logging for Quick, and the idea that we can then just have all the implementations give us the same format. We can store this in a database, and then very easily create tools that just work on this single format that makes both the data in the logs and the tools very easy to share between implementers and stakeholders. I'm going to talk a bit about this format, but I'm not going to focus on the Quick specific stuff. I want to take more generic concepts behind it in the hopes that they are more broadly applicable. So the first thing you have to do if you define a new format is the format. And we could talk about this for the whole rest of the session probably, but my opinion is it doesn't really matter which exact format you choose, because it's quite trivial to write transformers that go from one of the formats to the other. Yeah, I had Yang on there first. I took it out because I knew the line would be to the end of the room. So, right, so let's skip this. Let's go to the interesting stuff. As far as I could see, there are 2 main types of logging that people were doing, summary and event-based. So the summary one is kind of interesting because it doesn't log anything until you request its logs. So the moment you request a log, it just sends you like a snapshot of the current application state. And if you want to do more fine-grained logging, you just up the interval by which you request these state updates. This is actually what was presented for HTTP2 in the beginning. There is a nice draft about that never really made it into its standard, but most of the H2 servers are implementing this. Sadly, there aren't many tools that also support this format. The second type of format is what most people are used to. It's a chronological log of events that are happening. The simplest form of that is just a packet log. This is, for example, what Chromium outputs for the network stack, and also the Quick trace format. So there's a second Quick logging format from Google that will be discussed in the talk after this one, and they use this approach. So our format is called QLog. We chose JSON just because we are creating web-based tools, and that integrates quite nicely with JavaScript. And we chose the event-based type of streaming because we want as much flexibility as possible to be able to do our debugging use cases. Now, don't get too hung up about exactly what this is saying. That's for the Quick working group. Just 3 things that are more generic. 1, we like to namespace the events with a separate category. This makes it very easy to say, I'm not interested in, for example, the HTTP stuff. I can just very easily filter it out or just not log that at all. The second very interesting thing is the 4th column there, which we have called trigger, but some other people are calling reason or cause. The basic idea there is that you can have the same event, but it can be triggered by various different things. For example, here you have a packet was determined as lost and is being retransmitted. In Quick, that can have multiple causes why this packet was deemed lost. And so usually you can infer which of these it was from context of the rest of the log, but it would be interesting if you have more explicit indication of that as well. Interestingly, qlog and QuickTrace, the Google format, were developed in tandem without us knowing anything about each other. And still, both of the proposals have this same concept of a trigger or a reason, which I think is a very clear indication that Google should hire me. But also that it's an interesting concept that we might explore a bit more. The final thing, that's not what's supposed to happen. Fantastic. The final thing is the actual per event metadata we would like to keep flexible as possible, so we just keep it as a normal key value based JSON object. Or we do like to keep the keys, even though it has a little bit more overhead, but it's a lot more explicit in what you're logging. So I've talked about event-based logging, and there are kind of different granularities that you can go into for that. So the top one is what you're probably used to. It's a simple packet log, and you log everything that's in the packet or the packet header. The one below that shows the exact same data, but it extracts a new type of event from that. So here in Quick, you have a connection ID that's in almost every packet. It doesn't change all that often. So it makes sense to extract it into a separate event. And I'm kind of hoping that the Quick people in the room have started noticing this, but this is actually a log of a buggy implementation. In Quick, the client proposes a connection ID. The server usually overrides that with its own connection ID, and the client is expected to immediately switch to the server's connection ID as soon as possible. That's not what's happening here. The client is only switching to that new connection ID after during the handshake phase, not during the initial phase. Just to make that more insightful, the bottom one is actually what you expect. You expect this change to happen at the third event, not at the fifth one. And this might seem like a bit of a strange example, but I included it here because this is literally what I encountered a couple of weeks ago. So I am the guy doing the JavaScript implementation, and apparently we had this bug in our implementation for quite a while. And just by adding this kind of more fine-grained event-based logging, I was immediately able to see, well, this new connection ID event is happening way later than I would have expected. I immediately found a bug because of that. So this has a lot of advantages. It also has disadvantages. In Quick, packets are based up over the smaller frames. You can imagine the implementation creating those frames upfront, putting them in some kind of a temporary buffer, and then only taking them out when it's actually time to create the actual packets on the wire. That means you have a kind of a disconnect between frame creation and packet creation. And so the question becomes, which frames are actually in which packet? That's almost impossible to see from this type of log. You could say here, we'll look at the size, but that doesn't really scale. What you could do is log the frames twice, which isn't very efficient. What you could do is not log the frames when they're created, only when they are being sent on the wire, which is what QuickTrace does. Which you lose a little bit of the buffering concept, but you have more insight into the network. You can also just keep it as is. This is what Chromium does in its netlog. You keep more insight in how, for example, memory is used, less on how to network. So this is kind of a different balancing act, depends on your use case, and I'm not quite sure yet what the best approach for this is. It's still an open question for me. So one of the key tenets of qlog is to be flexibility. I really want this to be usable, that people can also add their own type of events, their own categories of events as well, that it can fully replace what they currently have as a logging solution, which is quite trivial. And if they then want to share or use these logs in other ways, it's very easy to just strip out those custom categories. What the format also allows is it's easy to combine different logs. So if we step away from Quick for a second, we can imagine a kernel TCP stack logging. We want to combine that with HTTP information from the user space level. This should make it relatively trivial to integrate those two together. One of the consequences there is that tools should keep this in mind. They can't expect logs to always have all the information they want. Conversely, what the tools can do is say, I will only work correctly if I have these categories, these type of events, and this type of metadata. And you can even validate that upfront when you're given a file. So you keep a lot of flexibility, and at the same time, you be very explicit in what certain tools will do, which I think is a very nice combination of things. So we have these nice, fantastic event-based flexible logs. Where are we going to get them for actual processing and visualization? One of the things I really like about the HTTP2 proposal is that they said, let's use a well-known URL. So they said, you go to this URL and you just get the logs for the current connection that you are on. I propose to extend that to also be able to get the logs from all the connections that are currently on the server, or at least maybe the most recent ones. Not just on the server though, also on the browser side. This would again allow tools like WebPageTest to go like, I do a run, I automatically fetch the client side vantage point, the server side, combine them into a single log, and present this to the visualizer. This also scales very well to something like a interactive debugging concept, where maybe you have a server that you are tweaking some parameters with. You can just stream all these events as they happen over a HTTP-based link, and you can have a very nice visualization coupled to that as well. Now I can see some of the security-minded people in the room squirming a bit on their seat, because exposing all of this interesting log state at predictable URLs is not the best idea. I'm definitely no security expert, but I can see that there are several ways that we might make this practical in practice to be used. It might not be completely safe, it might not be usable in actual large-scale production environments, but especially there are, I think, enough options to make this safe enough to make it usable in practice. So in summary, what I think when we do logging nowadays, we mostly stay above that conceptual line. I think everything below the line is definitely very interesting as well, especially with something as complex as what we're doing nowadays. So we should be adding this kind of stuff as well, especially talking about Quick. We have some interop between the current Quick implementations. It's my opinion that there will be large issues trying to actually bring the current implementations into actual production settings. I think the people doing that will eventually succeed because they're very smart, but I think it might be a lot faster and a lot easier for them if we would have a standardized logging and a tooling tool set. I'm also currently running a survey on Quick, which you're all cordially invited to fill out, which we ask which of the Quick features are most important for your specific use case. One of the features we ask about is standardized logging. You can see that a lot of people seem to agree that this is an important aspect, continuing with Quick. Final slide, I promise. What I think we can do in the IETF is create recommendations. Say these are the types of logging that you might be doing, and this is the situations in which they might be interesting. This is the way you could expose them for automatic processing and how to keep that secure. Maybe we can even make like a sort of high-level schema for people to match their own things in. I don't think it's very useful to go super low level in the schema and then have like, you have to register new categories and event types with IANA or something like that. I don't think that's workable in practice. What I do think is that the IETF should say, you know, if you are starting work on a new protocol or protocol extension, you are expected to have a logging plan. You are expected to have a logging document, and early implementers are expected to implement this type of logging, at least to some degree, so that when you're finally done with all the work, you have kind of a sort of basic tool set and interoperable implementations that you can then start to debug with each other.
Gentlemen, do you have clarification questions? Discussion we take after the next presentation.
All right, that was it for me. Yeah. Thank you.
Thank a lot first. This was a great presentation. A lot of good points. So if you have actually questions, that would be great. If you have comments, you might just want to save them. And Victor, can you come up front already?
We have no clarification questions. However, we're just going to go ahead and stay in line.
It will be another half an hour. You have to stand there, right?
Management accepts the risk.
Actually, while the slides are going up, I did have a clarification question. I thought, Robin, you said you did not want to talk about Yang, but your last slide seems to suggest exactly that. But that's a question.
Sure.
Okay, thank you very much. That was a great presentation, and you might just come up front again later on for the rest of the discussion. Yeah, you need your machine.
Yeah, they'll come in.
Hello, everyone. My name is Viktor Vasiliev. I work at Google on quick congestion control. And I was asked to give a presentation about what we use for tracing at Google. And I intended for this to be a very big, long presentation about all of the free logging formats we have and how I'm only responsible for 2 of them instead of all 3. However, fortunately for everyone here, I got sick sometime in the middle of writing, so instead of giant presentation, I will only talk about the most important points, answer about how quick tracing differs for TCP, and those are 2 points I want you to take away. But anyways, let's start with just talking about what TCP does and like. So why do we collect traces? So the first question is, why do we need traces? And there are lots and lots of answers depends on who you talk to. And my perspective is, as a transport stack developer, it is important for me to see information about when I send and receive packet to debug congestion control. You can do much more with traces other than debug congestion control. You can debug flow control. You can debug cases where you think you should be sending X, but you are not sending X, or cases when you are sending too many X and that's taking up all of your CPU. But my perspective is I work on congestion control, so everything I care about is going to be from that perspective. There are many forms in which you can write traces, but the main point of traces, as Robin already pointed out, is you're recording events. That is, something happens, you write it down, you write details about it, and then you move on with your life until the next event happens, and then you append. And there are many, many layers on which you record events. The reported connection level events you should record, like opening and closing a connection. And then, so there are the main 2 different kinds of traces people are typically interested in are either stream level traces, what happens when you write on one stream or other stream, and why do you choose to write that particular stream at that time. And this is important when you have a complex priority scheme and you want to debug that. However, Gquick doesn't really have a priority scheme, so I don't care about that. So we're going to talk about packet level events. That is, events which are related to packets. There are 4 main types of events related to packets. 1, packet can be sent. 2, packet can be ACKed. And this is from perspective of sender. 3, packet can be lost or retransmitted, and we'll talk about the difference between those 2. And the number 4 event, which nobody ever writes, the sender can run out of data. That is, the sender can discover that there is nothing to send. That event is surprisingly important. I'll talk more later about why. So there are traces. There are many ways to collect traces. You can collect them at sender. You can collect them at the receiver. You can even try to collect them in the middle of the network. You won't get so much useful. If you're debugging congestion control like me, you're collecting them at sender because congestion control is something you do at sender. So all traces I'm going to show are from the sender's perspective. So in TCP, you usually, the way you start your tracing is you just take you run TCP dump, you get a PCAP file, you optionally remove actual data sent on wire because you presumably don't care if you're debugging TCP. This is how it looks like. How many people in the room have seen this wonderful screen? Okay, so some people can read this. I can't. Nobody actually reads this in this format. Usually what you do is you draw a graph for this, and there are many graphs you can draw. You can draw throughput, you can draw goodput, which is different from throughput. You can draw RTT, you can draw loss rate, you can draw your receive window, or you can draw a thing called time sequence graph. And time sequence graph actually has all this information you need, including all of the preceding, and is the only graph we're actually concerned with, which is good. So the way time sequence graph works is it has an x-axis, which is time. That's easy to understand. Y-axis is the TCP sequence number. Hopefully, the tool you're using has subtracted the TCP SYN sequence number, so you can actually figure out. Some tools won't do that, so you'll have to figure out where you're in the connection. And so you draw a line where you send a packet, and you can draw send packet, and you can draw acknowledged packets with 2 lines, and those lines effectively tell you when you sent and when you believe we got an acknowledgement from peers that things you've sent were received. And then sometimes you can draw selective acknowledgements. There are a lot of various ways in which you can draw selective acknowledgements. Our internal tool at Google draws them in a very interesting way, which keeps crashing my browser. Especially if they're like, the worst pattern is when you receive a packet and then all even packets are missing, but all odd packets are there. Then it definitely starts behaving very, very poorly. Anyway, so this is the most canonical way to draw a TCP transfer. This is me uploading a file to Google Drive. The yellow line is receive window, which is not important here for our purposes. The green line is X, and the white dots are send. And you can't actually see them apart because we're zoomed out too far. You can make Wireshark draw the very same diagram. Here, if you zoom in, you can actually see those bars are the send packets, and the green line is the cumulative acknowledgement line. Okay, now this is an actually good idealized diagram of how to read the time sequence plot. So the 2 important facts to notice about this plot is that the slope of a line is the rate, is the bandwidth. For send line, it's the rate at which you're sending, your pacing rate, or even if you don't do pacing, your send rate. The green line is your cumulative goodput, i.e. the rate at which you're actually receiving data that's usable by application. The horizontal distance is RTT. It's the distance between the time you sent and the time you received an acknowledgement. And the vertical line is your effective congestion window at that moment. It's well, it's not even a congestion window. It's an estimate of your bandwidth delay product, which is, I guess, the same thing if your congestion control works well. So how many people are familiar, have seen this graph and like understand what I'm... Okay, good, because I'm going to talk about how quick... and before we go further, so this is what happens when you lose stuff. When you lose stuff, you have to, at time t, we receive a selective acknowledgement, which effectively tells us it works as a duplicate ACK. It tells us we should rapidly retransmit all data between SA and SB. This diagram is important because the quick diagram will look a little bit different. So here you can see the cumulative acknowledgement stops at the point where we're lost, and then you have to wait an extra round trip to retransmit all of that data to make use of SB to SC. Okay, so in Quick, the big problem is that we don't have a sequence number. We have packet numbers. And in Quick, we can take all data and retransmit it as new data, and we do not retransmit packets one for one. The way it usually works, you declare data lost, and then when you decide, when the moment comes for you to decide what to write, you first look whether you have data to retransmit and retransmit that data, and only after that you transmit new data. But we still can simulate this approach without loss, and it will look exactly the same in situation without losses. So the way you do it is whenever you send data in a packet, you look at all the stream frames inside the packet, and you assign a sequence number, which is not a real sequence number, to every piece of data you send. So in case of retransmissions, it's actually becomes more complicated, and there are two things you can do. One is whenever you retransmit data, you go in the past, you look, okay, when did I send the data and which sequence number I assigned to that data that I lost and decided to retransmit, and you draw that accordingly, and that looks like that, which is actually just the same diagram. There are many problems with, so there are nice things about this. The most important nice thing is this looks exactly like TCP. The not nice thing is, number one, in Quick, you're allowed to not retransmit data that you have lost. So there will be situations when data is never retransmitted because it was sent on a stream that got reset. And once you reset a stream, you no longer retransmit data on that stream, even if it were lost. And our old tool we used at Google, it was a TCP-based tool. It had a lot of trouble whenever things like that with reset streams happened. The tool just dropped drawing the ACK line. The ACK line was just stuck flat at the middle of the connection for the rest of the connection. So that's one of the reasons this doesn't work. So there is a second approach, is that you just treat retransmissions as new data, and actually the conclusion here, the way you look at the situation is that every data is either acknowledged or lost. And once it's acknowledged or lost, there is no need to follow up with retransmission, because so this is this diagram of TCP worldview, and this is the same diagram in proposed Quick worldview. Note that there are no retransmissions. The data gets sent and it gets lost, and then some data gets sent again, and you can see there's wonderful pointer. Data may be retransmitted here, because ultimately if you think about this from Quick worldview, there is no difference between you retransmitting old data and sending new data, because it's all just data, and Quick allows you to pick priorities between those two. It allows you to decide in the middle of the connections that high priority stream is actually low priority, and you don't even want to retransmit data that you sent once. And I feel like this is the important takeaway number one I want everyone here to take away. is that in Quick, there isn't really such thing as a retransmission from congestion control perspective. The event you care about is data being lost. Because as soon as the data is lost, all of the congestion control implications of losing data happen. Like you remove it from all bytes you have in flight, you have a loss event which tells you to scale your congestion window down or whatever your congestion controller tells you. Okay, so the second important message is you should, whenever you do logging, you should try to write down as much information from the actual congestion controller as you can. I will give you a couple of stories about why this is good, this is important, and you should do this. What information I'm talking about, the information, so the most important information you can write down is your congestion window, at least for Reno, Cubic, and window-based algorithms. If you're doing BPR, you also really want to write down your pacing rate because BPR is rate-based. You want to write down your bytes in flight because that number is very important for congestion control, and it can be different from what you expect. And it is very important for all of those numbers to be exactly what you expect, because if they're not what you expect, you will have bugs and very weird performance issues. Speaking of weird performance issues, okay, let me go and tell some stories about congestion control bugs we found. And the most important and the most famous one is the cubic bug. So the cubic bug is, there was a bug in Quick Cubic implementation, which was also the bug in Linux TCP Cubic implementation, which has existed for 8 years and nobody found it. And the way we found it is, so I was working as an intern at Google, and I was trying to add rich logging to our logging infrastructure. One day, I not only managed to land the code for that, but I actually managed to run a production server for YouTube with that logging on. And on the very, very first trace I've ever pulled in, we read through the trace and discovered that the congestion window at certain point of the trace just jumps up to obscene amounts without any apparent reason. So the underlying bug was that in a Cubic tries to be RTT independent. So the Cubic equation is written in terms of congestion window as a function of time. And it is written with the assumption that you're sending your data continuously. However, if you ever stop sending and then you wait for like 5 seconds and then you resume sending, what will happen is you will not, in original Cubic implementation, you will be stuck at the point where Cubic will think that it has been successfully sending data for all of those 5 seconds. And it will be at the point where, so the way Cubic works is that it starts at the very bottom, it tries to reach a plateau, it spends some time at that plateau, and then it decides that it's done and it's time to probe up, and then it just skyrockets its congestion window. And in Cubic bug, that part in the middle was skipped and it just jumped at the skyrocket congestion window part. And the only way we found it is we took that table and it was obvious in the very first trace. And it had a dramatically positive effect on both Linux TCP and especially on Quick, because in Linux, there was a safeguard against C-Wind rising too fast, and the quick version didn't. So we got dramatic improvements in our retransmission rate, and you can see there is a blog post. Funny thing, the way I learned about that bug actually being fixed was I was no longer an intern, and that was a blog post I read on the front page of Hacker News, and that's how I learned that the bug we found was actually fixed and was actually important. The other success story is during development of VBR, I wrote code to log almost every single parameter that BBR has inside of it in logs. And that was very handy because BBR, unless you know the state, the trace will tell you very different story depending on which BBR mode you're on. And even the TCP BBR version, so there's no way to do rich logging in Linux kernel TCP. But I know for a fact that TCP BBR team has similar tool, and I think they have printfs into kernel logs, which logs the current state, and that's the way their tooling works because they don't have anything better. But that's the second takeaway I want everyone to see, is that you should put as much rich logging, detailed congestion control information in your traces as possible, because that's the way you find bugs. All right.
So thanks very much. I think that's a similar message like Robin was giving us, that like consider it at design time, I think. And Brian, we have one more short presentation.
I need to stretch my legs anyway. No, I don't have any.
Okay.
I don't have any.
You can stand there now.
Yeah,
Might make sense.
At least move over so Yari can go.
Oh.
So thank you very much for this presentation and the insights.
Okay, so my name is Jari Akko, and together with my colleague Markus Ilar, we've been working on this from one particular angle, and wanted to come here and talk about this, and maybe together looking at a problem like logging from different perspectives will help us end up in the right place on overall solutions. And this is going to be pretty quick. So I have just a few pieces of background information, like where are we coming from, why are we thinking about this, and from what perspective. And then I have one slide about some recommendations on how to approach this space. And the first item is that Markus and I have been working on a piece of open source software that is initially was like measuring the quick spin bit behavior, and was able to determine RTT from those connections, but also grew into a tool that you can use to measure all kinds of different protocols and their behavior, RTT, and some other parameters. It's basically an in-network tool that is sitting somewhere in the network node and observing traffic passing by, and you can use it to determine some of these parameters like round-trip delays, and you can use it for network debugging. You could use it for research, like does this type of traffic behave well, or what the impacts of some new algorithm are. You could also use it for operations, like perhaps even raise an alarm when some of the parameters are behaving oddly. The other piece of background is that we're usually thinking about things in terms of a distributed system. So first of all, we're obviously not thinking about endpoints so much. We think about networks, but you could also think about endpoints and network nodes together. But in any case, so there's like multiple places where you can get information about a particular situation, and you can combine that information in some fashion together, and perhaps get more data than just looking at from one data source, basically what Robin was also saying. The third piece of background is that like what have we actually been doing in concrete sense in terms of logging and such. And there's really, like if you look at the piece of software that we wrote, SpinDump has 3 things to talk about. One is how do you deliver stuff somewhere? Secondly, what is the format of your data? And finally, what is sort of the semantics of the data, or what nature the data has? For our case, when we do measurements somewhere, we either, things can scroll on the screen, or you can store it on a file for your research analysis or whatever. But you can also deliver it to a server over HTTP or HTTPS, basically posting to a particular URL. And then the format question, so we started out with human readable text and JSON, or possibly adding binary format in the coming months or so. And on the screen, you will see the JSON variant of this, and we track multiple different kinds of events. We talked about the event-based mode earlier. And for us, there's multiple types of events. Like one is like, now there's a new connection on QUIC or TCP or whatever it is. And then there's measurement events and so on and so forth. And then finally, like the nature of the data, it's not just about like individual packets necessarily. You could also consider that like you deliver this batch of events, like you deliver one event or a batch of events, or you could even aggregate information, let's say over time, and then inform some receivers as well. During the last second, we received 1 million packets, and the average RTT on these types of connections was let's say 12 milliseconds. So there's lots of possibilities here, and just not only the question of like what the actual format looks like. So that's the background, and then to my observations, I want to make basically 5 statements. And this has been already said before by Robin and others, that unification in logging approaches and formats would be useful, really useful for interoperability and our ability to actually debug things, for instance. That's really essential. So I fully support that. The other thing I want to say is that let's consider different uses. It's not just about debugging or not just looking at your congestion control algorithm or some other specific aspect. There are many things that we could do with data from either in-network or endpoints in different situations, whether it's doing some research on some type of traffic, network optimization, debugging, or many different possible goals. So let's consider that. The third thing is that indeed it would be useful to combine information from multiple sources. We'd be very happy to do things that where we could, for some research purposes, to combine data from endpoints with in-network nodes. And then the fourth point is that it would be like, it was tempting at the beginning to think about, like, okay, let's optimize. I want to have CBOR instead of JSON or protobufs or whatnot. And that was very tempting, but it on purpose held back a little bit, because there's more to be gained by thinking about, like, depending on what you do, like, think about it from a semantics perspective, that are you delivering, 1 million events or one event, and let's optimize that first, and then figure out what the actual format is. So we've tried to focus more on the bigger questions than the details. And finally, particularly since we are looking at this from an in-network perspective, and to begin with, we don't have a lot of information. It's all of the keys and content and so forth is hidden as it should be. But there is some information still, like IP addresses and so forth. So we actually also want to think about things like anonymization. So our approach is that we can, wherever we're measuring, we can anonymize the information already at that point and deliver the anonymized data somewhere, and then therefore there isn't like this huge database anywhere that would have ability to track, like, what did this IP address do and so forth. So I find that very useful. And yeah, so this is pretty much it. So I think I'll leave the rest of the time for discussion.
Thank you very much. Yeah, we open the floor now.
Hi, Brian Trammell. I want to thank the presenters and the area directors very much. This was one of the better BOFs I've been to in a while. It feels a lot like a BOF. And I'm wondering if this is the point at which we can hum for the formation of this working group, because I am all about this. It's a little bit of a joke, but not really.
We don't need a buff to form a working group, actually. Right?
Oh, awesome. Well, let's just do it then. No, I'm serious. I think you need.
Do you want me to do it, or do you want Magnus to do it?
Do I get it earlier if you do it? Okay. No, I think we actually. I think that I would be very interested in. I don't want to even ask for hands from the floor, but I would be very interested in knowing who would be interested to do work on this. I would be very interested in doing work on this. I think this is something that's necessary for going forward in the future. This is a good way to replace, in a lot of the context that we've been worried about, a lot of the visibility that we're going to be losing when we're going to Quick. I will make an observation on observation. Anonymization is not helpful for research. It is absolutely imperative. Anonymization is maybe not so much, maybe not, wait, hold on. I can't even triple negative that, can I? Anonymization is also useful in debugging, because when you're talking about investigating a problem with a piece of code, you might not want to say, okay, well, only the people who can help me on this are people who are in the same authorization domain for access to potentially personally identifiable information and so on. I think that anonymization and how you do access control on this is actually something that will be key to having impact with this in a working group going forward. And I'm actually answering all these questions if they're off questions. The other thing that I would say is that I think I see a lot of synergy between the type of architecture that Jari is working on and what Victor and Robin are working on. I think that, yeah, it's not an either or. It's not just logging or just observation. Like, one of these things is observability. The system tells you what's going on inside it. One of them is measurability. You can derive metrics from the packets as they fly past. And I'm really interested in the possibilities of being able to unify these in sort of a unified view of things. So I'm super excited about this. And yes, I think we should form this working group, and we should meet in Montreal. Thank you.
Jana Iyengar. So I want to echo the sentiment that I'm very grateful to the ADs and to the speakers for having come here and done these presentations. One of the biggest concerns I've had for quite a while now is around tooling for Quick, because we all know that performance work requires good tooling, and it's one thing that people are building in various forms and ways, but it's really difficult for everybody to build really good tooling around this. So having some actually combined effort and joint work go into building tooling is super helpful. I don't think that's fully happened yet, but at least the fact that there's so much work going into tooling now is very, very good to see. Just in terms of the importance of this, for those who haven't really been looking at using tooling yet, I'll note that as soon as we started using tooling in Quickly, for example, we caught a bunch of bugs immediately. And that's, when I say tooling, I'm talking specifically about we integrated with Quick Trace, for example, and we were able to catch a bunch of bugs. And we still haven't caught everything, but it's super, super helpful. And for getting good performance, it's going to be absolutely critical. And that's where a lot of Quick's wins are, because the promise of Quick is in delivering better performance than you would get with HTTP2 over TCP. And to get there, we need to have super good tooling. So yes, I'm totally on board as well. And I've been talking to both Victor and to Robin, and I'm very happy to help with moving this forward into some sort of standardized logging format so that we can actually have implementations right to that. And hopefully not Yang.
Tom Herbert. So I agree, this has really been a very good presentation. I do hope this work goes forward in some regard. So that being said, as a protocol developer, I think this is fantastic. It's obviously very powerful tools, and we can make protocols better. As an end user, this is terrifying. Collecting data at clients, at servers, in the network, being able to correlate them, that's exactly what an attacker does. So page one of anything like this should be, what are the security and privacy implications of logging and collecting this data? And if you cannot answer that question substantially and sufficiently, none of the rest of this matters. So as an end user, I am not willing to trade any privacy or security for the ability to help debugging or network operations. So we can get past that, I think it's great. So obviously that's, I think the core, should be a core issue here.
Eric Kinnear, Apple. I just wanted to say that this is both very interesting and excellent presentations, and as an implementer, this is something that would be very helpful for debugging prior to deployment, and I'd be very interested in adopting to make some of that happen, whatever form this ends up taking. To that end, once we're talking about deployment, I think it comes back to a lot of what Brian was saying around how do you do anonymization and make sure that you don't have to compromise. So I would be very much willing to participate in that and try to help find a way where we don't have to make compromises for the security or privacy of the actual end users.
Andrew McGregor, Fastly. The privacy issues just have to be solved because this data exists anyway. It can be made to exist by instrumenting an implementation, whether or not the original developer put it in there. So it's just got to be done.
Yeah, I basically got up to say exactly that. I think anonymization is super important and we should totally do it. But today, the information that you can get at the endpoints with TCP dump is basically what you can get here for quick. And so it's not any different than that.
I'm going to ask if Roland had a question on this. I have actually another topic, Brian Trammell. We had 3 presentations now about instrumenting quick. That's, the transport protocol that is at the forefront of our minds right now. Some of them were focused on maybe H3 over quick. I'd say it makes sense not just to look at H3, but quick as a generalized transport as well. One question that we have to go into in the working group I don't have an acronym for yet that we're forming right now is the to what extent would these logging formats need to be sort of like transport general, right? And I think a good thing to look into would be, let us presume that TCP had been designed with a wire image that looks like Quicks, right? And what? You call it Quick?
We can have the buff here, but we don't have to have the whole working group meeting here, right?
Take it to the list, but we need to get a list. So Spencer, can you get us a list? Oh, we need an acronym though.
Yeah, QPPM.
The 3 of us are here all week, so at least 2 of us at any moment will be able to approve that.
So, Aaron Falk, this is a little bit of a trivial comment, and I don't know if anybody other than, say, Christoph will appreciate this, but looking back at sort of the evolution of performance measurement, I remember Tim Shepard presenting TCP plot and Matt Mathis talking about the Web 100 kernel. And boy, it really feels like we're living in the future here, that this is so much more expressive, and things have progressed so fast. So you guys can complain all you want, but things are a lot harder back in the old days. So I think this is my way of saying I think this is a really interesting and important work. With the usual caveats of trying to figure out what we should do in the IETF versus what people should do elsewhere. It seems like I'm in favor of it.
Okay, thank you very much. So, so that was actually an honest comment that you don't need a buff to get a working group, right? So I think what I really hear is that you want a way to continue this discussion with a mailing list in the first place. But then if you want also a venue like working group to talk about this, then I think you have we all together have to consider what the starting point is and which aspects should be part of this working group as a start at least.
Jana, I want to gently push back against that. I think there's a lot of good work going on right now, and I think a working group might have the exact counter effect of what you really want right now. I think what you want right now is agility. I think what you want right now is better tooling and integration with various implementations. I think we want to drive work, that's already happening. We want to sort of give it a boost, but I don't think there's a lot of standardization work that we need to do yet. So to that extent, I mean, I think that that's the only work in here that we may want to do is integrating the logging formats or having a unified logging format so that implementations do not have to spit out 15 different formats of logs. And that's something that, at least for a first run, is basically a draft. It's not a working group. So I'm going to push back against that just because that delays things, but that's what I want to say.
Okay, now we actually. Okay.
Gori Fairhurst. Yeah, I don't think we have a charter, so we don't have a working group. We have an intention to do something, so I back Jana. Let's find space at the IETF to talk about this, and let's find a draft.
That was what I wanted to say.
Ronnie Evan. I like the presentation, but there was some difference between the first two and the ARI presentation in terms of the scope and what it was covering, and I think we need to look at what we want to achieve in the logging, whether it's a general tool, whether it's protocol specific, and how to deliver that information. And I think we need some standardization on that.
Robin Marks, I want to give a bit of pushback against Jana there. I think the quick specific use case can be split up, can be kept agile, and work next to a potential working group. The working group can go broader. That's exactly what I think you had in mind as well, Mirja, by doing a more general presentation for me. So we can maybe view the quick work as kind of an interesting segue and to get to get some experience with what we want to do as a starting point for discussion in a broader working group. But I'm not sure, and that's something I might want to hear from other people, is how much potential do you see for this for things other than quick? Is it actually something that people want to see?
David Black wanted to support the idea of doing a structured log format. Up in more general sysadmin space, the log formats are not all that good. We have these wonderful tools called log scrapers. Sometimes they scrape up what you want, sometimes they don't. So I think just the log format would be incredibly useful. I also like the sense I'm hearing, let's go solve the problem for quick. And when we figure out how well it works and what were good ideas versus not so good ideas at the time, then generalize.
Okay, and before Spencer is allowed to run out of the room, I want to open the floor for like more general open mic questions to the ADs, if there are any. And I will wait for like 30 seconds. Or maybe less. Okay, then I have enough time to thank Spencer again, and thank you everybody for the session, and see you next time.
Thank you all.
You're on your own. So long, sucker.
Sure. I have like 1 minute.